Hello class, this is a example video of using multi-stage probabilities with with removal. So here's the example we'll be doing. A bag contains 3 blue, 3 red, and 4 yellow balls. 2 balls are randomly selected without being replaced. Create a tree modeling the scenario. So just to simulate this, I want you to imagine that you have a bag of balls. There's 3, 6, 10. There are 10 balls in there. You're going to take one out, place it aside, don't put it back, and then we reach in and we grab another one. So this is the scenario that we're attempting to create a tree diagram from. So I've actually already done it here. Hope you've given it an attempt. Again, use pencil for this because this gets rather difficult. But here is what the tree diagram should look like. I've blacked out the probabilities and the total ending bits at the end here. So as you can see, we could get a red and then another red, or we could get a blue, another blue, or a yellow, a red, and so on. Now for each of them, notice how they should have a probability on them because they are not all the same. Reading this, the probability of getting a red is 3 out of a total of 3, 6, 10. So I put here 3 out of 10. The probability of selecting a blue, we'll take a look. That's 3 out of 3, 6, 10. And once again, 3 out of 10. And you can probably imagine for this one, it's 4 out of 10 because there's 4 yellow balls. Now, for the second ball, if we follow this path, we've already selected 1 red ball, which means the probability of selecting the next red ball, well, there's 1 less. So that's 3 out of 10 for selecting the first ball, and then 2 out of 9 for selecting the second ball. Whereas for blue, there's still 3 balls because this path here, we've selected the red ball, meaning the blue ball has not been affected. Same goes for yellow. There's still 4 out of 9. And I hope that this is starting to make sense. Let me just erase all of these now. I hope it's making sense as to how we get these probabilities onto the branches. And I want to point out very importantly that if we follow this path, we've selected blue, it's 3 out of 10. But if we were to follow blue again, notice how it's 2 out of 9. There's 1 less blue ball to select if we follow this path. And lastly, it's always best to write down all the total results and all the combinations for them at the end. So calculate the probability. The 2 balls selected are blue or yellow. Well, to get blue or yellow, that's blue, yellow, that one there. It's probability of blue, yellow, plus, well, as again, this condition doesn't specify whether it's blue, yellow, or yellow, blue. So let's calculate that one as well. So this one here, plus the probability of yellow, blue. Calculating blue, yellow, that's blue, that's 3 out of 10, times yellow, 4 out of 9. 3 out of 10 times 4 out of 9. Plus yellow, blue, yellow, blue. Following that path, we get 4 out of 10 times blue, 3 out of 9. Going straight into our calculator for this makes it a lot easier for us. 3 out of 10 times 4 out of 9 plus 4 out of 10 times 3 out of 9. That gives us 4 out of 15. Here we go. Moving on to the next example. What is the probability that the balls selected are of the same color? I want you to go ahead, pause the video, and figure out which of these we're trying to calculate. Well, for the same color, that's red, red, blue, blue, or yellow, yellow. Writing that out, that's the probability of red, red, plus the probability of blue, blue, plus the probability of yellow, yellow. For red, red, that's 3 out of 10 times 2 out of 9. 3 out of 10 times 2 out of 9 plus, for blue, blue, 3 out of 10 times 2 out of 9. It's the same thing. And for yellow, that's 4 out of 10 plus 3 out of 9. Oops. Calculating this straight into our calculator makes it a lot easier. For this calculation, I'm going to do one of these and then multiply it by 2, because that's 1 and 2. So that's 3 out of 10 times 2 out of 9. I'm going to take that answer, multiply it by 2, plus this probability on the right for yellow, yellow. That's 4 out of 10 times 3 out of 9. Once again, this gives us a 4 out of 15. Let's calculate the probability that the two balls selected are of different colors. Well, if you take a look, there's quite a lot of probabilities for that. That's red, blue, red, yellow, blue, red, blue, yellow, yellow, red, yellow, blue. This would take us a very long time to calculate, so why don't we use what's known as complementary events? Well, the probability of different colors colors, that is the same as not the same color. Not the same color. Well, the idea of not the same color is the same as probability of same but not the same. So it's the remainder of this, which is 1 minus the probability of the same. That's 1 minus 4 out of 15. That will give us 11 out of 15. So the probability of selecting two different colored balls from this scenario is 11 out of 15. So I hope that gave you an insight into creating weighted probability trees without replacement. And I know these were rather difficult questions, but I hope that gave you a challenge as well as an insight into questions such as these. Hope to see you in the next video. Best of luck.